So, welcome to Unreal's class system. In this video, we're going to be introducing the idea of inheritance as it applies to programming. Unreal's scarily powerful class system is there to be used. It's both scary and powerful. It's huge. You can do a massive amount with it, but you need to understand how to access it and how to navigate around it. So we'll be using the class viewer to do that. And inheritance is for is-a relationships, and components are for has-a relationship. So that's what we're going to explore. The star, by the way, just links you to the class view, a little bit about it in Unreal's documentation. Remember, you can click these links in the section notes PDF, and they should take you straight there. Okay, cool. Let's dive in. So welcome back. It's time to start actually writing some C++ code and making it interact with things in our Unreal game already before we get too excited and comfortable with this pretty editor. Let's start working out how to broaden our horizon completely to the full idea that we can do things in C++ and Blueprint and really take control of this wonderful engine. Bear in mind that once you've started to master C++ and how it relates to Unreal, then in principle you could go in and edit the source code of the engine and do pretty much anything. So let's start this off by talking about inheritance. Inheritance in programming works quite like it does in terms of bloodlines in animals and in humans. So for example, a character in Unreal is a pawn and a pawn is an actor. Let's compare that to a dog is a mammal and a mammal is an animal. So on the right hand side, the actor and the animal, they're the most general things, and you can define general behavior of actors and animals over there. In the middle, the pawn and the mammal, they have all the shared properties of actors and animals, but then they go ahead and add some more detail, like mammals have milk, and in the case of Unreal, pawns are possessible and can receive control input. And then you go down to a dog, which is a specialization of a mammal, and a character in Unreal has the benefit of being a movable, bumpable object, like a first-person character, for example. So we'll see more about that later. Unreal makes extensive use of inheritance. It's a powerful tool if used properly, but it can be really inflexible and hard to refactor if you overuse it. So in this course, we'll be sticking to 2 or 3 levels of inheritance in our own code at the most, and trying to keep our hierarchies what we call fairly flat. And then we can use another tool to add richer behavior, which is components. Now, components are for has-a relationships. For instance, the chair and the rock in my scene, when we finished, will have a position reporter. We're going to add a component up here, the same component to both of them, called position reporter, like that, okay? So I'm going to delete that off there for now, but I wanted to show you the example. They will both have something called position reporter, and it will give the same behavior to both of these things. Objects become rich through having many components in this model. It can be very flexible if it's used properly, but we do need to use it properly, and we need to know when to use inheritance and when to use components. And the rule of thumb is inheritance is for is-a, components is for has-a. Okay, cool. So back in Unreal, I want to show you something. I want to show you how big and impressive Unreal's class system is. If we go to Window, Developer Tools, and then you have Class Viewer. Click on that for me. I've got it maximized. I'm also going to go to View, Collapse All, and Filters. I'm going to untick Actors Only, and even untick, well, doing that will untick both, actually. So Collapse All, Filters, not Actors Only. This is all of the top level objects we have in Unreal. It's huge, it's bewildering, but if you want to see this hierarchy I just talked about, an actor is for anything in the world that is interactable, even a chest or a door. Coming down from actor, there's a lot of things that come straight off actor in the family tree. One of those is pawn here, which as you hover over it, it says it's the base class of all actors that can be possessed by players or AI. They're physical representations of players and creatures in a level, okay? And then you expand pawn out and you find character. Characters are the pawns that have mesh collision and built-in movement logic. So you can explore the inheritance tree here. If you want to keep it simple, you can say actors only, and then that brings it down to just the actor-related things. There's still plenty of them. All sorts of stuff, including like Leap Motion, which is that cool hand tracking thing, or it just goes on. There's so much stuff. Unreal comes with so much stuff. That's a blessing because it gives us a huge amount of capability out the box, and it's also a curse because we have to understand how it works. So here we are back at Unreal. We're going to add our very first C++ component. What I'm going to do is click on my chair. You can click on any static mesh component. Or any static mesh object. How do I know that this is a static mesh object? Well, there's a hint here. But another thing that you could do is you could go to World Outliner from the window, and you'll see that all objects in the scene tell you their type down here. You have the world itself, some fog, and then you have the floor, light sources, player start position here. And then the chair and the rock, in my case, are both static mesh actors. That means they're meshes that don't move, they're not skeletons, and they're actors in that they are somewhat interactable. So grab a static mesh actor. I'm going to use a chair. Go to Add Component in the Details tab or window, and then add a new C++ component. It's going to be an actor component because it's a component of an actor, and I'm just going to call it Position Reporter because that's what it does. The chair has a position reporter, or just position report is shorter. Okay, so it has a position report. Now, there is a naming convention for components, but don't include it here. It's actually going to be you in this case, but don't include it because Unreal will do that for you. Let's create the class. So what's happening here is fairly heavyweight. Unreal's doing a lot of work. It's controlling Visual Studio for us, or Xcode on the Mac, and it's creating a load of code and a lot of boilerplate. And in a moment, we're going to be able to see that. It's going to open up in your IDE like this. And if we drill down into Games, Building Escape, Source, and then into Building Escape again, you'll see positionreporter.cpp&h. It's made the header file for us, which is quite bewildering. It's also made a CPP file for us.
It's important to note that in your position report.h, the header file, your last include should be this .generated.h file, and that should always be the case in any of these files that are generated for you. So if you do get some errors, do check that first.
Okay, now there's a load of stuff in here, and this is all completely new to us. Look how it's named things, by the way. It's called the class uPositionReport. You see over here, class. And it's kind of hidden in all of these what we call header tool directives, and also we've got macros in here as well. There's a couple of different things to catch you out, but it's put a U in, uPositionReport, so it's doing the naming for us. Okay, the header file's more scary. It's got a lot of weird stuff in it. The CPP file is quite a lot simpler. I will just tell you now that begin play, here is where you're going to want to put code that runs once at the start of the game, and under tick component, this is where you're going to want to put code that runs every frame. So all I want you to do now, actually, is make sure that you have created your position report component, and then what I want you to do is take a look at the generated code. Take a brief look at the CPP file, and take an even shorter look at the header file, but share what you recognize in the discussions. You know, I recognize what? Maybe I recognize inheritance, or maybe you don't because you didn't grasp that, or maybe you recognize some methods or whatever. What do you recognize, and what do you not recognize in there that's really weird? And what we're going to do is we're going to explore the files in a moment in the rest of this video, and then a little bit more in the next video as well. Okay, welcome back. So I just want to talk you through very briefly, then in the next video we're going to dive in and actually start coding. So let's start with the header file, as this gets cut and paste to the top of the CPP, as all header files do. So here it's saying fill out your copyright notice description in the project settings. Let me show you where you do that. Unreal, Settings, Project Settings, and then you've got over here, you've got company name. I'll put mine in, Embrace IT Limited. Company distinguished name, now that means it's unique. Homepage, support contact, and then further down here you can also fill out copyright information. Okay, copyright, I'm going to say Ben Tristram 2016 or something. Okay, now that won't immediately update your code because your code was already generated, but that's the copyright notice filled out if you want to do yours. Pragma, once it puts in for us, it does a couple of big hash includes. This thing here is telling the Unreal header tool how to work with this class. Okay, so there's going to be a lot of this stuff in Unreal C++. We just want to look past it for now and try and see the wood for the trees. Also ignore this thing here. But what we've got is a class called Position Report that inherits from actor component. Okay, generated body we need to leave there. Again, that tells Unreal's header tool to do some magic. Then we just have a declaration of the constructor, a declaration of begin play. It has this virtual word, which means that we're not actually saying exactly how it works here. We're going to be responsible for that somewhere else, but we'll talk about that later. And then you have the declaration of a tick component. Over in the CPP, it's less scary somehow, because you just come in here, and this is the constructor, sets it up and says this thing ticks. Things that tick, by the way, means that this bit of code will be run every single frame on every item that ticks. So if we want to sleep components or stop them taking up resources, we turn that off. We'll look at that later. This here is a method called begin play, which is a part of the uPositionReport class. And this super begin play says, do whatever happens up the stream, up the inheritance tree. Whatever's supposed to happen in the thing that I inherited from, the actor component, do that first, the default behavior, and then here, where on line 24 on my code, this is where we put our new code. And the same with the tick component. It runs the super behavior, the behavior for the things up the inheritance tree. We leave the engine to do that. Then we put our own code in here. So that's it. That is an overview of what happens. I'm actually going to close everything down right now, and then I'm going to make my commit, saving the level, over into my source tree, make a commit, and then we'll start coding in the next level. So once it notices, it should notice the things that have changed. Then I'll be able to save those, commit, and go from there. But I won't do that live with you because I like to do a couple of things just after the video to make sure that everything's in order before I commit and finalize the video. But okay, I'll leave it with you. You make your commit, and I will see you soon.
Just a quick bonus video for those of you who are using a Mac. If you are on Windows, you can skip past this to the next video, no problem. So, if you ever see this kind of build error in your build in Xcode, then the chances are you have got the wrong scheme selected up here next to the play and stop button. So if you scroll down, you want the building escape scheme selected and then my Mac, and that is the one you want. So just select building escape and then hit Command B. Command B is build, or find build in the menu. I almost never do that. I always build with Command B, but product build is the other option, and that should work just fine. But if you try and build the engine, it won't work in Xcode. This is also a good time to have a look at our gitignore file for Xcode. So I'm going to open up source tree here, and you can see we've got a few more unstaged files that it's talking about. And if we had built this Xcode project for ourselves and we wanted to track it, we'd still want to ignore some of these files. For example, the XC user data. We don't want that. That's setup that's particular to our machines, and we wouldn't want to share with other developers, for example. So we can right-click, ignore, and go down to custom pattern. And what I'm going to do is do a **/XC user data. I make sure I have to spell it correctly. And this basically says anywhere where you find a folder called XC user data, no matter how many levels deep in the folder hierarchy, just ignore everything beneath it. So if we hit OK, and you can see that those files disappear. And then in this case, we want to ignore the XC workspace as well, because we can generate that automatically from Unreal. So I'm just going to ignore this exact file name and hit OK. And then we just need to stage our gitignore, and we can do the appropriate commit. I'll leave that to you to do.